So as Daniel introduced, I will guide you through the ideas that are behind the Sunshine E-infrastructure and tell you about what is the current status of development of the E-infrastructure. So it's something we are developing, and we want to hear from you your opinions and suggestions on how to continue the development. So what is the aim and the structure of the E-infrastructure? Basically, the infrastructure is a tool for data collection, management, and assessment. So it means we can perform several different assessments with the data that we collect, and we can obtain different results. The data that is intended to be used in the infrastructure relates to nano-based products. And in this case, a product is also a nanomaterial itself, but also a product containing nanomaterials. Data refers to physical-chemical characterization, toxicology, and all the information about nanomaterials. But it also relates to the product itself, as we also integrate environmental, economic, and social assessment in order to help deciding when moving to the next stage of the agile stage gate process. So there is a lot of different heterogeneous information that can be collected in the infrastructure and assessed with the different tools. So a lot of data comes from different sources. So we have two main sources from data, which is the Sunshine database, which is connected to Nanomapper and other databases, and the data directly coming from users involved in the assessment. So users can share their own data with other participants in the same product, for example. So this data goes to supply chain partners, and when you input data, you always specify in which part of the supply chain you are when supplying the data. It also can be used for regulators which wants to dig into specific results or parts of the data if the users wants to share this information. So the data that is used might come from different origins, meaning that hopefully you always have measured data. So you apply some kind of a tool or a laboratory assessment or whatever, and you come up with some measured data. Sometimes this is not possible. So the infrastructure supplies a set of models that can be used to derive data that is missing. Of course, there are some models that are not exactly deriving data, but performing grouping, read across, and similarity in order to fill in gaps, starting with data already in the database. And of course, because we also have a social, economical, and sustainability aspects in general, it is also possible for users to just include their expert judgment in the tool. So whenever some information enters the infrastructure, it must be categorized in some way. So it always needed to know in which life cycle stage the data was measured, which supply chain stage the actor supplying the data is part of, and in which phase are we in the agile stage gate stage assessment. So we always need to specify where this data belongs. So once data is input to the system, several modules able to derive results that are then useful for assessing, for making decisions about the product can be run. So the main results that can be obtained by the infrastructure are about risk assessment, both human health and environmental risk assessment, also benefits coming from the product that are mostly related to economic and social assessments, an overall sustainability assessment, which integrates information from the environmental, the economic, and the social assessment. Then there is the safe and sustainable by design assessment, which integrates all the sustainability and the risk assessment part. And finally, there is benefit-based agile stage gate decisions. So the tool taking into account all the information and also some questions posed to the user can help in deciding whether to move to the next stage of the stage gate process, and also which alternatives should be moved to the next stage, because of course when you are developing a product you usually have more than one candidate you could develop. We also have some secondary results, which means some results that are used in order to get the results of the main part, but they can still be used alone by themselves. So application of IATAs for efficient testing, application of the in silico model, and also of the grouping and read-across models. So all of these can be run separately without having to do the overall assessment. So in this figure, we can see how things are structured in the EInfrastructure. So first of all, we have a product. Let me check. Okay, so we have we have a product that is the thing that we are assessing. It can be a nanomaterial or a product containing a nanomaterial. Then we need to specify in which stage we are working. So for example, we are still in the scoping phase. Then we must specify, okay, the data inputting is related to some alternatives. So we might have two separate alternatives that we might be developing. Then the lifecycle stage, synthesis, formulation, use, or end of life, and the supply chain stage. Usually it's operations, but it can be anything else. So all the information is structured this way. At some point, you might have to decide, you should decide to move to the next stage of the stage gate process. And then you might just want to move one alternative and not both, because the assessment might tell you so. So in this case, the data is just moved. The data that makes sense to be moved is moved to the next stage, and the other data should be updated to continue moving along the stage gate process. Another thing about data is that you can always export the data that is in the system so that you can have it in Excel files or other type of table data that can be used in any else system. And most importantly, you can link products inside the EInfrastructure. It means that if you are developing a nanoparticle and this is used inside another product, both users can include their products, and instead of having to copy information of the nanoparticle to the product using it, you can just link the two projects, so the two products. So data is the key part of the tool. So there are basically two types of data management here. One is open data. That is collected through Nanomapper and goes to the Sunshine database. And the other one is the private data, which is managed by a blockchain infrastructure. So the open data is data widely available, supplied by project partners related to the specific nanoforms studied in Sunshine and in other European projects mainly. This data can be used directly by producers if it's exactly the same as the product they are developing. Otherwise, it's usually mainly used for similarity grouping and read across. Then there's the private data, so the data specific to the product that's assessed. So this is provided by the partners. It's only available to registered users that are allowed by the data owner to see the data. And this data, of course, relates to specific characteristics on the product. So we mentioned blockchain, and as this is something new and it's important in the setup of the infrastructure, let's just focus for a second to blockchain. So blockchain is basically a ledger, and this ledger is by definition immutable. So it is encrypted using cryptography, and it is used to record all the transactions that's happening to the data inside a network. So there is a Sunshine network, there will be a Sunshine network with several nodes that are exchanging information. But every time information is used inside this network, this generates a transaction, and this transaction is stored in the blockchain. And so this ensures that every time data is written or is read, we know who provided and who export the data. So this is managed in a distributed way, so there is no central point, and so this ensures trustability and the immutability of data. So just to give you an idea, when a transaction is issued, some defined verification nodes that can be partners in the Sunshine project verify the transaction according to the encryption that is obtained from the previous transaction blocks in the blockchain. If the transaction is validated, then it takes part in a block. Then the whole block is validated, and the one single copy of the block is accepted by the whole network. And then the new block becomes part of the ledger, and it is used for the cryptographic key of the next block. So this ensures that every time a transaction makes it to the ledger, then it's not modifiable, because otherwise you should modify all the previous blocks and transactions. And this is not possible because they are replicated in all the validation nodes. So this is how we obtain security and privacy and everything for the data of private users. So as we said, we have two sources. So as you can see on the right side, the public data is provided by you, by project partners, by anyone who's participating in the Nanomapper database, and this is open for reading and writing. And then if a user of the Sunshine infrastructure wants to supply data for a specific product, this generates a transaction. So he writes the data, this generates a transaction, the validators validate the transaction. If it is accepted and validated, then it goes to the database, and the ledger reports this transaction. So we know who provided the data, when, and everything. At the same time, if someone wants to export the data, then this is an export transaction. Again, it should be validated. If accepted, then the data is supplied and the transaction is in the ledger. So every data can be followed, where it goes and where it comes from. This transaction methodology is used whenever data is provided, whenever data is exported, and when products are linked one to the other, because data is moving. Instead, when a user is just using the infrastructure, the data is available in the screen, so it can be read and used, but not exported unless you create a transaction. So this is how we develop this. So just an example of how it should work. So this is a producer of the Sunshine project. So Laurentia Technologies is producing an anti-stick and hydrophobic nanoparticle. So this is their product. They are in the scoping agile stage gate phase. And the idea is to create an SiC core plus DO2 shell type of nanoparticle. So this is an alternative because they can obtain the same product even with different type of a core and shell nanoparticles. So what they do is they start specifying that they are in the synthesis lifecycle stage, for example, and they are regarded as nanomaterial producers in the supply chain stage. So they start, for example, with the physical-chemical characterization. They can load data from the Sunshine database. They might as well include their own data by using blockchain transactions. All of this blockchain is completely transparent to the user, so you don't need to know anything about it. Whenever you include data, the system generates blockchain transactions for you. Then they might need to follow IATAs to understand exactly what they should measure if something is not already in their hands. Then the data can be related to the whole nanoparticle or to the components of the nanoparticle. So they produce the nanoparticle and they also produce the TO2 component, but they are purchasing the SiC part. So this part comes from a supplier. This means that they can ask the supplier to log into the system, create their product that is only SiC, and then link this product. Like we said before, this linkage goes through a blockchain transaction and the data provided by the supplier is directly usable by Laurentia. Of course, if some data is missing and they cannot measure it, they can apply the similarity grouping and read-across module that again makes use of data from the Sunshine database. Then they shall move to the exposure scenario part where they again can import their data. They can, through the tools that are provided in the infrastructure, they are able to create different activities with their contributing scenarios and evaluate human exposure and environmental exposure through the use of models, and also include risk management measures which are directly provided by the SL database from TNO through APIs. So this allows them to have an idea of hazard and exposure, for example, and they also have a risk assessment tool available in the infrastructure so that they can evaluate risks. They can again do the same for life cycle assessment. So the tool that we are trying to include in the infrastructure starts from LCA impacts that shall be evaluated outside the infrastructure, but can be imported by blockchain transaction again. This shall be compared. So different scenarios can be compared against each other, and they might be compared against a benchmark that could be also part of the Sunshine database. Very basic benchmarks can be found in the database. The same goes for the social lifecycle assessment, but in this case, we are also developing a simplified tool for self-assessment. So something like a questionnaire that is easy to answer to. And then if someone wants to go more in detail, social lifecycle assessment shall be supplied. And same goes for the lifecycle costing part about the economic figures. You can do the simplified tool or input the specific impacts. So all of this is then used by the system in an integrated way to establish sustainability assessment and safe and sustainable by design assessment. So all of these orange boxes are tools that can be found in the tool, in the infrastructure. So each tool can be used separately, but then these broader tools, they integrate results from the previous ones. So it's a hierarchical structure of assessment. What you can get in the end would be something like this. So matrices where you can see for each alternative production of your product, which are the status, what is the status according to the safety and the sustainability, and then you can go deeper and subdivide in smaller pieces and go on like that until you get to understand why you are in a risky situation, for example. Then all of this information, alongside with other information supplied by the user in a questionnaire type, goes to this agile stage gate assessment module that can help in deciding whether to move and which alternative shall be moving to the next stage. Again, it can happen that we have another producer, Mario, which is producing bread baking trays. He's in the scoping stage, and he would love to use these anti-stick hydrophobic nanoparticles. So just to say again, the first step for Mario would be not to perform the physical-chemical characterization of the hydrophobic nanoparticle, but just to link, so asking to the supplier that we already seen before to provide this data through their product inside the infrastructure and link them through a blockchain transaction. So as we have seen, there are several assessments we can do. We can decide for stage gates. We can compare alternatives according to risk assessment or whatever aspect. We can evaluate which life cycle stages are impacting more. And we can compare alternatives which are different just for the supplier's part and compare them according to life cycle assessment, for example. So there's a lot you can do by utilizing these separate tools that also integrate things together. Then this is the current development status. So physical-chemical characterization is already available. Then we have some tools that are updating for the new infrastructure. So the tools are already there. We just updating them to be included and migrated in the new infrastructure. So risk management measures, environmental sustainability, economic sustainability, risk assessment, all of this is in migration. The orange ones are in development. So the exposure scenario part, the social sustainability, the safe and sustainable by design assessment, the stage gate assessment, and the blockchain technology. These are in development in Sunshine and will be included in the infrastructure. So we started already the development and we have a very first prototype available in our development channel. It is based on results from Gracious mostly in this moment. And you can already find features like physical-chemical characterization, IATA application, nanomaterial risk assessment. We also already have implemented the client-side API that is able to connect to the Sunshine database. And also we are connecting with the TNO for the risk management measures. As we said, we're migrating from database version 2 to database version 3, but it's already available. So what's ongoing, still ongoing now, we are updating the models, as said. Those response and inadvertent oral models, for example, are under update. We are including these exposure scenarios and activities. So you will be able to specify exact activities you are performing. We are updating the social LCA assessment that was already developed in the past in SANS. And we are migrating the sustainability assessment models from SANS again, because we changed the software infrastructure, and so everything needs to be adjusted. And of course, we are in development of the blockchain technology. So finally, the next steps is, of course, to complete all the updates and include them in the prototypes, which will go to version 2, complete the migration of tools, and finally develop the models and methodologies that are still not there. So the stage gate assessment, the overall sustainability assessment, and the refinement of grouping and read across, which will be definitively part of the e-infrastructure. And with this, I thank you, and this concludes the presentation of the contents of the e-infrastructure.
Thank you, Alex. Thank you very much for this presentation. And looking at the chat, I can see a couple of questions that we can answer very fast right now before we proceed. So the first question comes from Barbara. It is how do you control the quality of the data that is entered into the database? So maybe I could take this question just to explain that we developed, we have worked in the Gracious project, and now this work continues in the Go for Nano project to develop methodology approach for automatic assessment of data quality and completeness of physical, chemical, and hazard data. And there is a paper which we submitted last week. We submitted on Friday to the Nano Impact. But what is important for the infrastructure is that this methodology has already been partly implemented in the Nanomapper database, and also in the harmonized data entry templates that we use to enter data into the database. So for the moment, the implementation is mostly for completeness, and in the templates, every data provider can see in traffic light the level of completeness of the dataset. Also, the interface of the database provides such functionality. What we did then, we took this methodology and we developed an R tool, which will be also implemented in the EInfrastructure. So the infrastructure will include functionality that is related to that actually enables assessment of quality and completeness of PhysChem and hazard data. And there are also ongoing developments for exposure data, and hopefully in the future we'll be able to also implement this.
Thank you. That was very important. And I really think this is more and more important for all of us, that we really can provide all this detailed information so that we can put the data in a context. So that's really important. Thank you.
Thank you. Then the next question, it's agree with Barbara. Also, in silico model could retrieve different results. I'm not quite sure. So can Federica elaborate a bit further on this question? What is exactly the issue with the different results?
Yes, you can the data that are.
We cannot hear you. You're very low.
Oh, sorry. You can hear me now?
Yes, I think we can hear you. It's a bit not very strong, your voice, but we can understand quite well what you are saying.
Okay, so the data that are loaded in the system can also be retrieved by models. Is that correct? In silico models, I think.
Yes, it is correct. The data that is fed in the infrastructure through the database, but also it could be fed through external data set and also other databases. This data can be chained to in silico models. And actually, this is now in development in the nanoinformatics project. In nanoinformatics, we're developing a modeling platform with which chains the data to the models. And a substantial part of this work will be migrated to this EInfrastructure. Yes. And in silico assessments will be enabled, which I think is relevant and important for the early stages of product development, just to avoid very costly experimental tests involving animals.
Okay, thank you.
Thank you, Federica. Okay, next question. How do you maintain the infrastructure after Sunshine? So for in our project in Sunshine, we have a special task about developing an exploitation plan and actually a business plan for maintaining the infrastructure after the end of the project. And this work is still in progress. And actually, there are some questions regarding this also in the discussion part of this little workshop, so that we can also brainstorm with you what will be the best options for ensuring long-term perspective for.
Is it only me or Daniel stopped?
Yeah, he disappeared
as well.
Oh, sorry.
For all of us.
Anyway, I guess what he was saying is that this is, oh, he's back, I guess.
Yeah, something happened and Zoom just disappeared. Sorry about this. So for the moment, we just maintain our tools ourselves with our own company investment and also funding from European projects. But we understand the importance of coming up with a robust longer-term perspective for this kind of tools, and that's why we have this task. We're going to develop a business plan, and we would like to discuss this also with you a bit later in this workshop. Okay. There are quite a few database initiatives through European projects. What are the plans to incorporate them beyond Nanomaterials? The way this infrastructure is working is quite open for connecting also to other databases, and Nanomaterials is one separate example of a database that we would like to work with because it's more modeling friendly. So certainly we have this functionality, and maybe Alex can tell us a bit more about how other databases can be connected to the infrastructure.
Well, basically what we are doing is we are using APIs. So whatever data source is providing an API for supplying data, we can try to connect to the system if we can, again, download data from the database and associate data types to the data types required by the models. But this is technically feasible, again, providing that the sources database give access to the information.
So in any case, we're quite open to work also with other databases, and hopefully enough databases will include data that are also relevant for this more complex multi-component advanced materials. Thank you, Marianne, for your question.
Perfect, thank you.
And then the last question by Max is what does this tool make nano-specific? Is it applicable after modification for all materials in principle? Yes, this tool is nano-specific in its models. The tool includes a number of models for exposure assessment, occupational exposure assessment, environmental exposure assessment, material flow models, environmental fate models, which are nano-specific. These models were developed in nano safety projects, and they're really addressing nano-specific properties. So applying the infrastructure with these more nano-specific models makes it nano-specific. But it's quite, we're developing it as quite open and generic infrastructure that can easily link also to models which are not nano-specific and databases which are not nano-specific. So in this sense, the infrastructure is quite flexible to address also all materials in principle. And it really depends on which models will be connected and which databases will be connected. And a lot of the features of the infrastructure, like the playground for information exchange through blockchain, for example, the methodologies for sustainability assessment and also for comparing safety, functionality, and sustainability of different design alternatives. All these things are rather generic, and they can be applied to all materials in principle. I hope this answer was sufficient. Alex, is there anything you would like to add with respect to these questions?
Well, you've been pretty clear. So yes, for this last question, it's many parts of the tool are already applicable for any type of material because they are not directly related to nano. And as you said, it's only a matter of which models and which data you use, but the tools are generic enough, mostly.